Okay, today we are going to understand the key characteristics of EX atmosphere. Here we understand about the flammability limit. What is name itself suggests flammability limits, the limits under which the flammability occur. Limits which is minimum and maximum concentration of gas in an atmosphere within which the air plus gas mixture can be explosive. This is called flammability limit. So this flammability limit is defined in particularly two way. First is minimum limit and another is maximum limit. Minimum limit we can call it lower explosive limit, that is LEL, and maximum limit we can call it upper explosive limit, that is UEL. Now we are going to understand the more detail about the minimum and maximum limit of gas concentration present in an atmosphere. Here you can see in this picture the gas concentration is there. Suppose it is below the minimum limit, lower explosive limit, then this area will not be explosive atmosphere. This area will not become explosive atmosphere. In the second case here, you can see this concentration is more than the concentration which was given in the above picture. So suppose this concentration which is shown in this yellow is within range, that is within if it is within range of this minimum and maximum limit, it means lower and upper explosive limit. Then what will happen? This area will be EX atmosphere. Yes, of course, this area will become an EX atmosphere. In the third picture you can see here the gas concentration, you can see clearly the gas concentration present in this area is more than the gas concentration was there in the above picture, due to which this concentration goes beyond the maximum limit. The concentration is more than the required limit which can make the atmosphere explosive. It is beyond that, due to which this area will not become an explosive area. These two areas we can call potentially explosive area, but not explosive area, explosive atmosphere. This is potentially explosive atmosphere. This is potentially explosive atmosphere, but this is explosive atmosphere. Okay. Here you can see a triangle, a picture where we can understand the lower explosive limit, upper explosive limit in more detail. We have made a triangle here, and here you can see the air is 100%. If in this area, if anything going in this direction, air is increasing, and anything is going in this direction, gas is increasing. It means gas is minimum here and gas is maximum here, that is 100%. Here the air is minimum and the air is maximum here at this area, that is 100%. It means the gas concentration which is from 0 to 100% here, there is some lower explosive and upper explosive limit, right? So suppose at this point the lower explosive limit of this gas starts. It goes to a certain distance and it becomes the upper explosive, reaches to the upper explosive limit. If it's going beyond that, the gas concentration in an area, if it's going beyond that, it means the upper explosive limit has crossed, and this area which is beyond that will not be in an explosive atmosphere. So the area which is in range of this LEL and UEL, lower explosive limit, upper explosive limit, only this particular area will be an explosive atmosphere. The rest of the area here and these two areas are potentially explosive, potentially EX atmosphere, but this is not at EX atmosphere. So from this image you can understand the LEL, UEL of a gas present in an atmosphere, and this is the ignition source. Of course, any concentrated gas in an atmosphere requires the ignition source to burn or explode. This I have explained for the gas atmosphere, but for dust also. In the case of dust as well, the dust dispersed in an atmosphere. The concentration and quantity of the dust dispersed in the atmosphere should be sufficient for that atmosphere to become explosive. If it is lower than that concentration required to become that area explosive, then it is below the lower explosive limit, you can say. And similarly, the upper explosive limit, if it is the dispersed concentration of dust is beyond that maximum value in the area, you can call it is beyond that maximum upper explosive limit, maximum limit and upper explosive limit. In the case of dust also, it requires ignition source to ignite, same as gas. Okay, let's here discuss about the explosive gas atmosphere, auto ignition temperature, and explosive dust atmosphere, minimum ignition temperature. So here you can see there is a difference, that is here it is mentioned auto ignition temperature, here it is mentioned minimum ignition temperature. Auto ignition temperature is the minimum temperature of gas at which it can automatically ignite without any source of energy such as spark or flame. Okay, this it's only required a thermal energy from a hot surface. If the hot surface of any equipment in that area is more than the minimum ignition temperature of the gas, it will automatically ignite, right? That's why in the case of gas, temperature class of all the equipment becomes critical in selection. We study about temperature class in our further videos. Here we should know which temperature class of an equipment to be considered for a particular gas. So suppose if we are selecting equipment in a hazardous area where a certain type of gas is present, so we should know what is the minimum temperature at which that gas can be auto ignited. If the gas is present in that atmosphere, it can be auto ignited in normal atmosphere as well. So we should know about that temperature, and the surface temperature of the equipment should be less than the temperature of that gas. Suppose the gas is having a temperature of 100 degrees Celsius. Okay, so this gas can be ignited at this temperature, gas temperature. Okay, gas minimum ignition temperature. Ignition temperature. So any equipment selection, temperature should be less than 100 degree. You can say 90 degrees Celsius equipment temperature, the maximum equipment temperature. (90°C). So if the equipment maximum temperature is 90 degrees Celsius and the gas minimum ignition temperature is 100 degrees Celsius, so even if the gas present in that area will not auto ignite. So this is the auto ignition temperature. Every gas has its own auto ignition temperature. We can discuss the list later, but every gas has its own auto ignition temperature and we should be knowing about that temperature before doing the design. So that's why the auto ignition temperature comes in picture. But here you can see the minimum ignition temperature. It's not the dust which can ignite automatically. It there is a certain temperature. This is the lowest temperature of a hot surface on which the most ignitable mixture of dust with air is ignited under specified test conditions. Okay, so in a specific test condition this happens. Source of energy, again here also the thermal energy. Dust ignition temperature for most parts is 300 to 600 degrees Celsius. So if the surface temperature of the equipment present in the dust atmosphere, we should be very much known about that ignition temperature of that dust. That's why here it is mentioned, when deciding the maximum surface temperature of the equipment, we should know about the dust cloud present in that particular area. If you try to understand these two, it looks quite similar, but the selection criteria is a bit different. Here you can see the temperature class. Here you will not see the temperature class. Here is the maximum surface temperature is defined for every equipment. So there is a difference. So now let's talk about the flash point. What is flash point? So the flash point, flash is not fire. The first word comes to our mind, flash. Flash is not fire, flash is not explosion. Flash point means the minimum temperature. So we are going to talk about the temperature. Flash point is the temperature. That is the value of a temperature. Okay. The minimum temperature at which a liquid releases enough vapor to form an ignitable mixture in air. Minimum temperature. Flash point is what? It's a temperature. A minimum temperature at which a liquid release. We are talking about here a liquid. At a certain temperature, a liquid release enough vapor to form an ignitable mixture in air. That is called flash point. It requires external source like flame or spark or thermal energy from a hot surface to ignite. Knowledge about the flash point of a volatile liquid will help us in avoiding the formation of an explosive atmosphere. How? Suppose, for example, we know that there is a liquid present in a area which is non-hazardous. Okay, liquid, let's slide. So as soon as this liquid reaches liquid temperature reaches to its flash point, it means there's a temperature bar and the temperature is rising. There is a flash point temperature at which this liquid started releasing enough vapor, because anything below this, any temperature below this flash point will not release the enough vapor to form an ignitable mixture.